right-handed today?
Good
I'm good.
morning, ladies and gentlemen of Precalculus. Here it says in exercises 29 through 32, find the component form of the vector v. And here you're given like a graphical form that gives you your magnitude and your direction. So how do you find the component form of this vector? And it goes back, when I started talking about vectors, remember that one day where I just kind of lectured about vectors? We saw the little video clip of vector, right, from Despicable Me. So what's going to be vector v in component form? How would you do that?
18 over.
When you do the same way, but do I forgot what it is. You'll
Okay.
do something different.
Yes, we will, okay? Remember the song I sang at the beginning of the year, the middle of the year?
Our sign is well, I forgot it now.
R sine.
Our cosine
Sign is
X.
X and our
is
sign is
X,
Y.
and our sine is Y. That's what that is. So we have is, what is R going to be? Magnitude equals R. So that's R. So that's X. So R is 18. Our cosine is X. So what this is our X coordinate. This thing right here is this distance right here. Okay, this distance from here to here, that is 18 cosine 25 degrees. That's what that is. And what is this next thing going to be here? What's our next thing here going to be, guys? Come on.
18 times.
Thank you, Karina. And mathematically, we have a correct answer in hand right here. Now the book wants you to go ahead and finish it off by putting these in a calculator and getting a numerical equivalent of just the number. So we go to our calculator, and I want to get to degrees.
Go to degrees, yeah.
So we get to degrees, and so we put 18 cosine 25 degrees. So 16.314. So 16.314, comma, and then we have 18 sine, there's my sine, 25 degrees. And so we have that, 7.607. And when we go ahead and find the magnitude of this, what are we going to come back to? 18, right? And we find the direction of this, what will we come back to? 25 degrees. Okay, now.
Do these for all of them.
Yeah, so what happens is we have a similar sort of thing. Okay, 30 is just like a dead center copy of it. So let me see. We'll start calling people. What I have is I have a couple people left to call on this one, so.
I have a question for 31.
For 31, okay, let's go to, okay, we'll get
Do
to,
you use the remaining degrees, because you do 180 minus 108?
that is a real good question. That is an excellent question. And I'm gonna handle that after Justin helps us with problem 30.
Okay.
A very good question, Dana. Okay, Justin, how did you do this one?
So x is 14 cosine 55 degrees.
So you have, so x equals 13, 14 you mean, right?
Yeah, point.
Cosine 55 degrees. And y is,
Is 14 sine 55 degrees.
so now it's just really a calculator button thing, isn't it?
For x, I got 8.03.
Okay. And
And for y, I got 11.468.
468, okay. All right, thank you. Elizabeth.
Hi.
Hi, Elizabeth. Since you're here. Well, Elizabeth, coming to class here for half a minute to help with the blood drive. Thank you, Justin. Good work. Appreciate that very much. Okay, yes. Batteries, okay. Yes, use batteries. Good job, Justin. Great working, man. Good job. Yes. Yeah, this is from the old set of batteries. Get the new ones. Once I get these batteries in here, we're going to take Jana's question. There we go. Starting to run low on batteries. I need to get Miss Van to help me out again.
Yeah.
See how this works? Yeah, let's do it again. Let's try it out. Okay, let's pay close attention on this next part because Jana just really asked a good question. So what we're given here is we're given an angle of 108 degrees. We'll call theta. And we don't have a reference angle, but we can draw one, can't we? And this one right here, we're going to call this angle alpha. And alpha is going to be equal to 180 minus 108. And if I'm not mistaken, is that 72? 72 degrees. So we have to handle we can use either one of these things, but we're going to handle these differently. Okay, now I'm going to try Jana's reference angle first, right? So we're going to have cosine. We have x is equal to cosine, or cosine, so we have to have 47, right? 47 cosine of 72 degrees, and our y, oh, I have to write down 47, excuse me. 47, our y is equal to 47 sine 72 degrees. So are these correct here? Okay, Justin's nodding, okay?
They were correct.
They are correct? Okay, let me show you something here.
Just like the other one.
If I put 47 sine, what was it, 72 degrees?
Yeah.
Okay, so we have this, right? No, I meant to put cosine. 47 cosine, 72 degrees. I get this, right?
Right.
But, watch this, if I put 47 cosine, was it 108
Yeah.
degrees? I get this. Okay, so one of these is right. Is it 47 cosine 72 degrees, or is it 47 cosine 108 degrees?
So you're right.
108 is right. Why is 108 right? Because second quadrant. Very good. Thank Jana. So Jana's keep. So what happens is, yeah, so my answer to Jana is, if you use a reference angle, you have to keep track of the sine, right? And so I know that's over here, so I know that's going to have to be negative, and now I'm good. Now this one right here in quadrant 2, this is going to be good because the sine of 72 degrees is the same as the sine of 108 degrees. But to me, the standard position is the one I like to use because that takes care of that sine problem for you. Okay, so so what you have is 47 cosine of 108 degrees, comma 47 sine 108 degrees. And then those are going to be, I did them in the calculator a second ago, so we got negative 14.524. Comma, and it just so happened we did this sine of 72, so that's going to be 44.700, right?
Yeah.
Okay, so that's what you should get there. All right. Are we ready to go on here to this one here? What I'm going to do is I'm going to get our remaining 32. Let me get my wheel here going. All right, this one here is going to be, this next one here is Karina. Karina, you are the young lady. What is this one going to be, Karina?
It's going to be 33 cosine 136.
So x equals 33 cosine 136 degrees.
And then y is 33 sine
36 degrees, okay.
And it's negative 33.738.
Negative 23, you said?
Yeah.
23.738.
738. Then y is 92.924.
22.924. Okay. Does that look right? Okay, good. Okay, we will go on here. Okay, 33, okay. Find the magnitude and direction angle of the vector. We've been doing this for a long time, so you know how to, have you done this one already, Jana? What'd you get, help us out, what'd you get, Janet?
I got for magnitude, the square root of 25, which is also 5.
So you got square root of 25 equals 5. So that's our magnitude, okay, and our direction,
Direction, I got 53.130.
okay, so that's gonna be this, right?
Yeah.
4, 3, 3. So 53.130,
Yeah.
has anybody tried the other things, like you could also do, if you wanted to, inverse sine of 4/5, right? Is that gonna give you the same thing? Yeah, it will. Okay, thank you, Jana. Appreciate that. So you should be able to get to these other ones here
Yeah.
pretty easy. All right, I have Robert do this one.
What?
Yeah, Robert, you'll do 34 for us, right?
Yeah.
Robert did 34. Okay, Robert, what do you think?
I got square root of 5 magnitude.
So magnitude equal, so you got this, right? You got like -1 squared plus 2 squared
Yeah.
equals square root of 5. Okay, good. Then, so that's your magnitude.
And then the other one's the inverse tangent.
Okay, so your direction is going to be inverse tangent of,
2 over -1.
so I'll say -2.
Oh, yeah.
Is that it?
Negative 63.43.
Now we're in which quadrant here?
Here.
Which quadrant are we in?
Wait. Second.
Second quadrant. So what do we have to do to this? Add 180 to that, so what do we get for that?
Oh, yeah, I forgot to do that. So it's 116.57.
57? So that's going to be our direction and our magnitude, okay? All right. Everybody's good on that? Okay, then we have these others. Okay, so now for 35 and 36, I think we're talking about linear combinations, aren't we? Let me see what we have for the rest of these, 38. Yeah, okay. Good, we got four people left here. So we have everyone and you do one of these. 35, 36, 37, 38, okay. Okay, I'm gonna put here,
Jay wasn't here yesterday.
Jane wasn't here yesterday.
No, I don't know what I am doing.
Oh, okay, you didn't do linear combinations yesterday, okay, good. But somebody else will have to help this.
and J is 0.
Okay. So I have, so Jana, you don't, did you figure it out? Did they tell you? Okay, we didn't do this.
I is 1, 0, and then J is 0, 1.
Okay, this thing chose Jana. I don't want this to choose Jana right
Like
now.
a Google coordinate thing.
What's the coordinate? Okay.
Okay, I got to close to Justin. So Justin, can you do this one for us?
Me?
Yeah, can you do this one for us? It's going to be,
Yeah, 1, 6.
so what we talked about, Jana, yesterday is now, so you're telling me you didn't watch class videos, what you're telling me?
Sorry.
Well, the purpose for it is just for when you're gone, right? You had one job. So these are called standard unit vectors, I and j. And in 3 dimensions, you call them I, j, and k. But in 2 dimensions, you call them I. So here, for this first one here, what you have is this is going to be equal to 3 times that standard unit vector 1, 0. And it's going to be minus 4 times this standard unit vector 0, 1. And so what you have here is if you distribute, you get 3, 0, and you have minus 0, 4. And so you add these together. What do you get when you add these together, Justin?
I
Or
got
subtract?
3, -4.
3, -4, okay? And what it is, and this is I made sort of an elaborate process out of it, but when you see these, you'll be able to, with understanding, go straight to here, right? That's not gonna be, okay, Justin, go ahead.
Oh, so for the magnitude, I got 5.
Okay, magnitude 5, and it's definitely a 3, 4, 5 right triangle. Magnitude equals 5, okay? And direction?
I'm still working.
Okay, direction. You got error? Let me show you here. So you have, what we're going to have is inverse tangent of -4/3 plus what?
360.
Plus 360, very good. And so you're going to have,
Oh, wait. I used the wrong negative sign.
oh, did you?
Yeah.
Okay, yeah, that happened. Yep. So what did you get for that, Justin? You get 200, 300 something maybe, or 200 something. I don't know.
306.8698.
8698, so that'd be like 70, right? Okay, so there's your direction, your magnitude. Thank you, Justin. Good work. Okay, next we got 36. Let's get, we're going to get to help us out with this. Remove Justin's next. Okay, here we go. Got one of you 3 remaining. Okay, this is gonna be Jana. All right, Jana. This one is you, Jana. What do you got for this one?
I only got the vector being -2.
Okay, so this vector here, you said -3, -5.
Yeah.
Okay. So that is our vector. What is our magnitude going to be?
Would it be a positive or a negative number? Because it's, I have 34, but I get -34, positive 34.
Okay, is magnitude ever negative? No, it's not.
Okay, so 34.
34, okay. Magnitude is never negative, but adjacent and opposite can be negative. So that's our magnitude, very good, and direction. Theta is equal to what?
Inverse tangent,
Inverse tangent
-5
of 5/3, okay. And what else?
Is it plus
Plus 180,
Oh, right.
so what is that going to be?
239 and 036.
036?
Yes.
Okay, so that is our direction. And this one right here, 37. Karina, do you have 37 figured out yet? Not too sure if you're right. Hang on a second, let me get this. All right, Karina, for magnitude and direction, what do you get for your magnitude here? So Karina says magnitude equals 7. Okay, what about direction? So theta is going to be equal to 135 degrees. So that will be our answer.
You worked it out, because I have no idea how you got any of that.
Okay, yeah, I'll show you what it is, but it's sort of, it's what it is. When you see something like this, you really don't have to work it out, because it tells you plain on the face what it is. I'll show you what it is. Okay, if we distribute here, we're going to get, that's going to be equal to 7 cosine 135 degrees I plus 7 times sine 135 degrees J, right?
Yeah.
And so what we have is that's going to be equal to 7 cosine 135 degrees. We have times I, which is this, right? Plus 7 sine 135 degrees, oops, 0, 1, right? And so we get, when we distribute here, we get 7 cosine 135 degrees times 1, so we can just leave this here, comma 0, plus 0, comma sine 135 degrees, or 7 sine, excuse me. 7 sine 135 degrees. And so you put these together, and you add these together, you get 7 cosine 135 degrees, comma 7 sine 135 degrees. And so what you have here is simply this. What you have is you got 7 cosine, so that's 7, so you got 135 degrees. That's your vector, and it's like this. Magnitude is 7, so that's 7 here, and this angle here is 135 degrees. So what this is the magnitude is 7, and the direction is 135 degrees. Okay? So that's really all there is to it. And then the last one we have is 38. So Robert, okay, magnitude equals 2, and direction is 60 degrees. Theta equals 60 degrees. And so, ladies and gentlemen, that's going to be it for today. We're able to finish in plenty of time.